A fair die is thrown until 2 appears, then the probability that the 2 appears in even number. So let us consider A is an event, getting 2, so that the probability of getting 2 when a fair die is thrown is 1 out of 6, and its complement A bar, that is not getting 2, we can say P of A bar is equal to 1 minus 1 upon 6, that is 5 by 6. And it is also mentioned that the 2 appears in even number of throws. So in first throw it will not appear 2. So the possibilities are A, A bar and A, and then A bar, A bar, A bar and A, fourth position. So even positions, and again A bar, A bar, A bar, A bar and A bar 5 times, and sixth time you can get A, and so on, so that it continues. Probability of not getting A is 5 by 6, and probability of getting A is 1 by 6, and here probability of not getting A is 3 times, so 5 by 6 whole power 3 into 1 by 6, and here probability of not getting A is 5 times, so we can write 5 by 6 whole power 5 into probability of getting A is 1 by 6, and so on. So we can take 1 by 6 common, so 5 by 6 plus 5 by 6 whole power 3 plus 5 by 6 whole power 5, and so on, which is equal to 1 upon 6 into, and this series is a sum to infinity in GP, whose first term is 5 upon 6, and the common ratio R is equal to 5 by 6 whole square, and sum to infinity in GP is A upon 1 minus R, so we can write A value is 5 by 6 upon 1 minus R value is 5 by 6 whole square, that is 1 by 6 into 5 by 6 divided by 1 minus 25 by 36, that is 36 by minus 25 divided by 36. So here we can write 1 upon 6 into 5 upon 6 into 36 divided by 36 minus 25 is 11. So 6 6 are 36. So the answer is 5 by 11. So we can go with an option A, 5 by 11. If alpha, where alpha lies between minus pi by 2 and plus pi by 2, is the solution of 4 cos theta plus 5 sin theta is equal to 1, then find the value of tan alpha. So it is given 4 cos theta plus 5 sin theta is equal to 1. So dividing with cos theta on both the sides. So we can say 4 plus 5 times of tan theta is equal to secant theta, squaring on both sides. So we have 4 square 16 plus 5 square 25 tan square theta plus 2 into 4 8 8 5 are 40 times tan theta is equal to secant square theta, and we have secant square theta minus tan square theta is equal to 1. So we can write secant square theta is equal to 1 plus tan square theta. So we may write 25 tan square theta plus 40 times tan theta plus 16 minus secant square theta, we can write 1 minus of 1 plus tan square theta is equal to 0. So we can write 24 tan square theta plus 40 times tan theta plus 15 is equal to 0. So we can write here tan theta is equal to minus 40 plus or minus under root of b square, that is 1600, minus 4ac, that is 4 into 24 into 15, divided by 2 into 24, which is equal to minus 40 plus or minus 1600 minus 15 4s are 60, 24s are 1440. So we can write 1600 minus 1440 divided by 2 into 24, or we can write minus 40 plus or minus under root of 1600 minus 1440 is 160, divided by 2 into 2 into 12. So we can write tan theta is equal to minus 40 plus or minus root of 160, we can write 4 root of 10 divided by 2 into 12, that is 4 into 12, which is minus 10 plus or minus root 10 divided by 12. So tan theta, since tan theta is equal to where alpha lies between minus pi by 2 to plus pi by 2, and alpha is the solution of this equation, so we may consider tan theta is, and tan alpha we can write minus 10 plus root 10 upon 12, or minus 10 minus root 10 upon 12. So we can see that this option is satisfying, root 10 minus 10 upon 12. So tan theta is equal to, which is tan alpha, we can say tan, where theta is alpha is a solution, so we can write tan alpha also equal to root 10 minus 10 upon 12, which is option A. A function y is equal to f of x satisfies f of x into sin 2x plus sin x minus of 1 plus cos square x into f dash of x is equal to 0. So we can also rewrite this as y into sin 2x plus sin x is equal to 1 plus cos square x into f dash of x, we can write dy by dx. And further simplifying, we can get dy by dx is equal to y into sin 2x upon 1 plus cos square x plus sin x upon 1 plus cos square x. So dy by dx minus sin 2x upon 1 plus cos square x into y is equal to sin x upon 1 plus cos square x. So which is in the form of dy by dx plus p of x into y is equal to q of x. So its integrating factor is equal to e to the power integral p of x dx. So we can write e to the power integral p is nothing but minus sin 2x upon 1 plus cos square x dx. So here we can substitute or put cos square x is equal to t. So we can write 2 cos x into differentiation of cos x is minus sin x dx is equal to dt, or minus sin 2x dx is equal to dt. So e to the power integral dt divided by 1 plus t square, which is equal to e to the power of integration of 1 upon 1 plus t square is tan inverse of t. Sorry, it is not t square, t. So we can write e to the power of integral dt upon 1 plus t, that is e to the power log mod of 1 plus t, that is 1 plus t. So 1 plus t is nothing but cos square x. Now the general solution can be taken y into integrating factor, that is 1 plus cos square x, is equal to integral of q of x, that is sin x upon 1 plus cos square x, into integrating factor 1 plus cos square x dx, that is y times of 1 plus cos square x is equal to integration of sin x dx, which implies, so we can write y times of 1 plus cos square x is equal to integration of sin x is cos x minus cos x plus c, and it is also given f of 0 is equal to 0, that means at x is equal to 0 y is equal to 0. So substitute y is equal to 0 is equal to minus cos 0 plus c. So 0 is equal to cos 0 is minus 1, here minus cos 0 is minus 1 plus c, which implies c is equal to 1, and therefore y times of 1 plus cos square x is equal to negative cos x plus 1 is the answer. And again, at x is equal to pi by 2, we can add y times of 1 plus cos square pi by 2 is equal to minus cos pi by 2 plus 1, that is y times of 1 plus cos pi by 2 is 0, which is equal to minus cos pi by 2 0 plus 1. So y into 1 is y is equal to 1. So f of pi by 2, we can say the answer is 1, which is option B, option 2. If the value of the integral minus pi by 2 to plus pi by 2 x square cos x upon 1 plus pi to the power of x plus 1 plus sin square x upon 1 plus e to the power sin x to the power of 2023 dx is equal to pi by 4 times of pi plus a minus 2, then the value of a is. So I can consider the integral I is equal to minus pi by 2 to plus pi by 2 x square cos x upon 1 plus pi to the power of x plus 1 plus sin square x upon 1 plus e to the power sin x to the power 2023 dx. And let us apply the property integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So here minus pi by 2 to plus pi by 2. So we will be getting f of pi by 2 minus pi by 2 minus x, that is f of negative x. So let us substitute and write I is equal to minus pi by 2 to plus pi by 2 minus x whole square into cos of negative x divided by 1 plus pi to the power of negative x plus 1 plus sine square of negative x divided by 1 plus e to the power sine negative x to the power 2023 dx. Upon simplifying, we will get minus pi by 2 to plus pi by 2 x square cos x upon 1 plus pi to the power of x, we can add 1 plus pi power x into pi to the power of x plus 1 plus sine square of x, because it is an even power, we can add sine square x divided by 1 plus e to the power of minus x to the power of 2023 is an even number, so we'll be getting minus sine x to the power 2023 dx, which on simplifying I is equal to minus pi by 2 to plus pi by 2 pi power x into x square cos x upon 1 plus pi to the power of x plus 1 plus sine square x into, we can write e to the power of sine x to the power of 2023 divided by 1 plus e to the power of sine x to the power of 2023 by taking LCM. Say this is 1 and this is 2. Adding 1 and 2, we get 2i is equal to integral minus pi by 2 to plus pi by 2. So we can say pi to the power of x or x square cos x taken common, x square cos x taken common. So we'll get 1 plus pi to the power of x upon 1 plus pi to the power of x, and again here 1 plus sine square x taken common. So we get 1 plus e to the power of sine x to the power 2023 upon 1 plus e to the power sine x to the power 2023 whole dx. So we can remove this and you'll be getting 2i is equal to integral minus pi by 2 to plus pi by 2 x square cos x plus 1 plus sine square x dx. And now, since we know that x square cos x, it is an even function and sine square x is also even function. So if I can replace here f of x as f of negative x, you are getting the same function. F of negative x is equal to f of x, so which is even function. So by using the property integral a to b or minus a to a, f of x dx, we can write 2 times integral 0 to a f of x dx. So 2i is equal to 2 times of integral 0 to pi by 2 x square cos x plus 1 plus sine square x dx. So let us simplify, let us evaluate the integral separately. So let me consider integral x square cos x dx by applying by parts. So we can write x square into integration of cos x is sin x minus integral of differentiation of x square is 2x into integration of cos x is sin x dx, and again x square sin x minus 2 times of integration of x sin x. So we can write x into integration of sin x is minus cos x minus integral of differentiation of x is 1 into integration of sin x is minus cos x dx. So we get integral x square cos x dx is equal to x square sin x, again minus of minus plus 2x into cos x, and again minus into minus plus, again integration of cos x is sin x, so minus again 2 times of sin x plus some constant c1. And now let us find integral sin square x dx. We know that cos 2a is equal to 1 minus 2 sin square a. So we can write sin square a is equal to 1 minus cos 2a upon 2. So we can write 1 minus cos 2x upon 2, which is equal to x upon 2 minus integration of cos is sin 2x upon 2 into 1 by 2 plus another constant c2. And now therefore we can find the limit integral 0 to pi by 2, that is I is equal to, we can write 0 to pi by 2 x square cos x plus 1 plus sin square x dx is equal to x square sin x plus 2x cos x minus 2 sin x and over the limits 0 to pi by 2, and again plus integration of 1 is x over the limits 0 to pi by 2, and integration of sin square is x upon 2 minus 1 by 4 sine 2x over the limits 0 to pi by 2, which on simplifying you will get pi square by 4 sine pi by 2 is 1 plus 2 into pi by 2 cos pi by 2 is 0 minus 2 into sine pi by 2 is 1, and again minus the completely the lower part will be 0, and again here also pi by 2 minus 0, and here pi by 2 divided by 2, that is pi by 4 minus 1 by 4 times of sine pi is 0, and again the lower part is 0. So you are getting pi square divided by 4 and again minus 2, and pi by 2 plus pi by 4 is 3 pi by 4, and which can be written as pi by 4 taken common, pi plus 3 minus 2. Now comparing with the given right hand side, pi by 4 of pi by 3 plus a minus 2. So we have a is equal to 3. So the value of a can be taken as 3, which is option B. Let phi comma a upon 4 be the circumcenter of a triangle with the vertices a comma minus 2, and b, a comma 6, and vertex c is given a upon 4 comma minus 2, where alpha is the circumradius and beta is the area of triangle and gamma is the perimeter of the triangle. Then find the sum alpha plus beta plus gamma. So here we can observe that from the first two coordinates a and b, vertex a and b, we can see that the x coordinate is constant, x is equal to a, which is the vertical line, and from the second coordinate and third coordinate b and c, we can see that, sorry, from the first and third we can see that y coordinate is constant, that is minus 2, so which is horizontal line. So y is equal to minus 2 and x is equal to a. So these are horizontal and vertical line, and now the point of intersection of these both, that is a comma minus 2, which is the vertex a, and a comma 6. So let us mark here the point b, a comma 6, and the point c is given a upon 4 comma minus 2. So let us assume that c is the point a upon 4 comma minus 2. So which forms a right angle triangle here. We can see that it is a right angle triangle, and we know that in right angle triangle circumcenter is the midpoint of the hypotenuse. Is the midpoint of hypotenuse of right angle triangle. So which implies the midpoint of BC is equal to 5 comma a upon 4, and here we can say that the midpoint is a plus a upon 4 divided by 2 comma minus 2, which is equal to 5 comma a upon and 6 minus 2 upon 2. So we can write 6 minus 2 upon 2 is 2. So 2 is equal to a upon 4. So from here we can say that a is equal to 8. When a is equal to 8, we can consider the points as 8 comma minus 2 vertex a, and vertex b we can write 8 comma 6, and vertex c is 8 upon 4 2 comma minus 2. Then the midpoint will be taken as circumcenter. Let us take it as s. 8 plus 2 divided by 2, that is 5 comma, and 6 minus 2 upon 2, 4 comma 2, that is 5 comma 2. So 5 comma 2 is the circumcenter, and so that the circumradius will be, from S we can take the distance to either A, B or C will give the circumradius. So let us find the distance from S to the vertex A. So SA distance is equal to root of 8 minus 5 whole square, that is 3 square, plus 2 minus of minus 2 whole square, that is 4 square, which is equal to root of 9 plus 16, which is square root of 25, is equal to 5. So the circumradius is 5, so we can denote alpha is equal to 5. And now the next one, beta denotes the area. To find the area, let's draw the diagram. It's a triangle with vertices 8 comma minus 2. This is A vertex, and vertex B 8 comma 6, and vertex C is given 2 comma minus 2, and the circumcenter is 5 comma 2. And since AC is the horizontal line and AB is the vertical line, so the distance between these two coordinates, like x coordinates, 8 minus 2, 6 units is the length of AC. We can say AC length is 6 units and AB length is equal to, and here the difference of y coordinates, since x coordinate is same, 6 minus of minus 2, that is 8. So the length of AB is 8 units, and the length of BC, and we know that the circumradius is 5 units, so 5 plus 5 will be 10 units. So BC is equal to 10. So area of triangle is equal to, which is beta, half into the product of the legs for right angle triangle, so half into 6 into 8, which is 24 square units. So beta can be considered as 24. And now gamma is the perimeter of triangle, so gamma is equal to perimeter of triangle, which is equal to sum of the sides 6 plus 8 plus 10, that is 24 units. So we can consider gamma is equal to 24, and alpha, the circumradius, is 5 units, we have seen. Therefore alpha plus beta plus gamma is equal to 5 plus 24 plus 24, that is 48 plus 5, 53. So 53 is the answer, which is option C. For x belongs to minus pi by 2 to plus pi by 2, if y of x is equal to given integral cosecant x plus sin x upon cosecant x into secant x plus tan x into sin square x dx, and limit extends to pi by 2 minus y of x is equal to 0. Then find the value of y at x is equal to pi by 4. So we can simplify here y of x integral cosecant x, we can add 1 upon sin x plus sin x upon 1 upon sin x into 1 upon cos x plus sin x upon cos x into sin square x dx. So which is equal to integral 1 plus sin square x upon sin x divided by 1 plus sin power 4x upon sin x into cos x dx, which can also be written 1 plus sin square x into cos x divided by sin x into cos x upon 1 plus sin power 4x upon sin x into cos x. So we can remove sin x cos x both in the numerator and denominator. So we can write this as 1 plus sin square x into cos x upon 1 plus sin to the power 4 x dx. So I can write y of x is equal to integral 1 plus sine square x upon 1 plus sine power 4x into cos x dx. So let us go with substitution method. Put sin x is equal to t, so that cos x dx is equal to dt. So we will get cos x dx is dt, and we can write integral 1 plus t square upon 1 plus t power 4 dt, and this can be simplified. T square common, so 1 plus 1 by t square divided by t square taken common, so t square plus 1 by t square dt. So which is equal to 1 plus 1 by t square dt divided by t square plus 1 by t square is nothing but t minus 1 upon t whole square minus or plus 2. X square plus 1 by x square formula we can write it as x minus 1 upon x whole square plus 2. So let us substitute here or put t minus 1 upon t is equal to some p. So differentiating we get 1 plus 1 by t square dt is equal to dp. So our integral can also be written dp divided by p square plus 2. So we can write integral dp upon p square plus root 2 whole square. And we know that integral dx upon x square by x square plus a square is equal to 1 by a tan inverse of x upon a plus c. So we can write 1 by root 2 tan inverse of p divided by root 2 plus c. 1 by root 2 tan inverse of p is nothing but we can write t minus 1 by t divided by root 2 plus c, or 1 by root 2 times tan inverse of t is nothing but sin x. So sin x minus 1 upon sin x upon root 2 plus c. This is y of x. That is y is equal to 1 by root 2 tan inverse of sin square x minus 1 upon root 2 into sin x plus c. Now it is given limit extends to pi minus y of x is equal to 0. That is, at x is equal to pi by 2, y value is 0. So we can write 0 is equal to 1 by root 2 tan inverse of sin pi by 2 is 1, 1 minus 1 0 upon root 2 into 1 plus c. That is 0 is equal to 0 plus c, which implies the constant c is equal to 0. So the function y is equal to 1 by root 2 tan inverse of sin square x minus 1 upon root 2 into sin x plus 0. Now we need to find at x is equal to pi by 4. At x is equal to pi by 4, so y is equal to 1 by root 2 tan inverse of sin square pi by 4 is 1 by 2 minus 1 divided by root 2 into 1 by root 2, which is 1 by root 2 into tan inverse of 1 by 2 minus 1 is minus half divided by 1. So here we can say 1 by root 2 tan inverse of minus half, which is our option B, option 2. Limit extends to pi by 2, 1 upon x minus pi by 2 whole square into integral x power 3 to pi by 2 whole power 3 cos of t to the power 1 by 3 dt is equal to. So let us write, or let us substitute x is equal to pi by 2. We can see that the denominator part pi by 2 minus pi by 2 is 0. and the numerator, that is integral pi by 2 whole power 3 to pi by 2 whole power 3, the same integral, we can get 0. So it is in the form of 0 by 0. So we can apply L'Hospital rule. Let us apply LH rule, differentiating the numerator and denominator. So limit x tends to pi by 2. So we may get the denominator differentiation 2 times of x minus pi by 2 into differentiation of x is 1. And the numerator part, so I can write d by dx of integral of x power 3 to pi by 2 whole power 3 into cos of t to the power 1 by 3 dt. So we have the concept differentiation of integral d by dx of integral f of x to g of x h of t dt is equal to h of g of x into g dash of x minus h of f of x into f dash of x. So by using this concept, we can write limit x tends to pi by 2, the denominator, that is 2 times of x minus pi by 2, and the numerator, so cos of pi by 2 whole to the power of 1 by 3 whole cube whole to the power of 1 by 3 into differentiation of pi by 2 whole power 3, that is 0, minus cos of x power 3 whole power 1 by 3 into differentiation of x power 3 is 3x square, which is equal to limit x tends to pi by 2 minus cos x into 3x square upon 2 times of x minus pi by 2. Or we can also write limit x tends to pi by 2, negative cos x we can write sine of x minus pi by 2, because sine pi by 2 minus x is cos x. Sine of x minus pi by 2 will be minus cos x. So divided by x minus pi by 2 into 3x square upon 2. And we know that sine of x minus pi by 2 divided by x minus pi by 2 when x tends to pi by 2 will be 1. So we can write limit x tends to pi by 2 sine of x minus pi by 2 divided by x minus pi by 2 into 3x square. We can write limit x tends to pi by 2 3x square divided by 2, which is equal to, here we can say the answer is 1 into 3 by 2 times of pi by 2 whole square, that is 3 by 2 into pi square divided by 4, that is 3 pi square divided by 8. So 3 pi square upon 8, which is option D. Consider the function f from 1 by 2 to 1 to r defined by f of x is equal to 4 root 2 x power 3 minus 3 root 2 x minus 1. And consider the statements, the curve y is equal to f of x intersects the x-axis exactly at one point, and the curve y is equal to f of x intersects the x-axis at point x is equal to cos pi by 12. So let us check for the first statement. Since f of x is equal to 4 root 2 x power 3 minus 3 root 2 x minus 1, and at the boundaries, if I can check, f of 1 by 2 is equal to 4 root 2 into 1 by 8 minus 3 root 2 into 1 by 2 minus 1. So which is root 2 upon 2 minus 3 root 2 upon 2 minus 1, that is root 2 minus 3 root 2 is minus 2 root 2 upon 2 minus 1. So which is negative. So f of 1 by 2 is negative, and then at the other point f of 1 is equal to 4 root 2 into 1 cube minus 3 root 2 into 1 minus 1. that is root 2 minus 1. Root 2 is greater than 1, so we can say this is positive. So from the we can check that at x is equal to 1 by 2 it is negative, and at x is equal to half, at x is equal to 1 it is positive. Means the graph cuts the x-axis at one point. And let us check, is there any maxima or minima in between 1 by 2 and 1. For that, differentiate and equal to 0. So we get 4 root 2 into 3x square minus 3 root 2 is equal to 0. So that 12 root 2 x square is equal to 3 root 2. So x square is equal to 3 by 12, which is 1 by 4. So the value of x can be taken here plus or minus 1 by 2. So at x is equal to plus 1 by 2, minus 1 by 2 does not exist in the interval. So at x is equal to 1 by 2, you are getting negative value, and this is the corner point, and hence we can conclude that the graph compulsorily cuts the x-axis at only one and only one point. So statement 1 is true. Now let's check the second statement. The curve y is equal to f of x intersects the x-axis at the point x is equal to cos pi by 12. So given function f of x is equal to 4 root 2 x power 3 minus 3 root 2 x minus 1. So this can also be written by taking root 2 common, 4x power 3 minus 3x minus 1. Let us consider, let x is equal to cos theta. So we can write f of cos theta is equal to root 2 times 4 cos cube theta minus 3 cos theta minus 1. That is root 2 times 4 cos cube theta minus 3 cos theta is cos 3 theta minus 1. And let us see this. Since to cut the intersect the x-axis, so we have to consider y is equal to 0, that is f of cos theta 0. So we get root 2 of cos theta is equal to 1, or cos 3 theta is equal to 1 by root 2, which is cos pi by 4. Then 3 theta is equal to pi by 4, which implies theta is equal to pi by 12. So at theta is equal to pi by 4, we are getting y is equal to 0. Means the graph cuts the x-axis at the point cos pi by 12, comma 0. So at x is equal to cos pi by 12, the graph cuts the x-axis. So we can say that the statement 2 is also true. So both the statements are true. So we can go with an option 1. Both 1 and 2 are correct. Let A is equal to a matrix 1 0 0 0 alpha beta 0 beta alpha, and determinant of 2a whole cube is equal to 2 power 21, where alpha and beta are the integers. Then a value of alpha is, so here determinant of a, we can write 1 0 0 0 alpha beta 0 beta alpha, which is equal to 1 times of alpha square minus beta square. That is alpha square minus beta square is the determinant of a, and it's given that 2a determinant whole cube is equal to 2 to the power 21. So we can write this as 2 to the power of 3 into det a whole to the power of 3 is equal to 2 power 21. Since we know that the property determinant of constant into a is equal to k to the power of n into det a, where n is the order of the matrix. So here order of the matrix is 3 by 3. So we can write 2 to the power of 3 into det a, and again whole power 3. So that is 2 to the power of 9 into det a whole power 3 is equal to 2 to the power 21, or det a whole power 3 is equal to 2 to the power of 12. or we can write determinant of A is equal to 2 to the power of 12 divided by 3. So det A is equal to 2 to the power 4. So that is 16. So det A is equal to 16 and det A is equal to alpha square minus beta square. So we can write here alpha square minus beta square is equal to 16. And since alpha and beta are the integers, the possible ways of writing is either 4 square minus 0 square, or we can write 5 square minus 3 square. So when 4 square minus 0 square, so alpha is equal to 4 and beta is equal to 0. And when alpha is equal to 5, so beta is equal to 3. So alpha is equal to 5. The value of alpha can be taken here, 5, which is option C. That is 5. If f of x is equal to function 2 plus 2x for minus 1 less than or equals to x less than 0 and 1 minus x upon 3 for 0 less than or equals to x less than or equals to 3, and g of x is given negative x when minus 3 less than or equals to x less than or equals to 0 and positive x when x lies between 0 and 1 where x is excluded 0, then find the range of the function f circle g of x. So let us sketch the graph of these functions. F of x function, we can see that from minus 1 to 0 and again from 0 to 3, from minus 1 to 0 the graph is 2 plus 2x, that x is equal to minus 1, so we will be getting 0, and at x is equal to 0 you will be getting 2. So the graph will be in this way, and again from 0 to 3 the graph can be taken as at x is equal to 0 it is 1, and at x is equal to 1 it is 1 minus 1 upon 3, that is 2 by 3, and at x is equal to 2 it is 1 by 3, at x is equal to 3 it is 1, sorry 0. So we can see the graph is coming down. So this is 2 by 1 by 3, and here is a point 1 comma 2 by 3. And coming to the graph of the function g of x, we can see that from minus 3 to 0 and 0 to 1, from minus 3 to 0 it is negative x. So we can draw the graph. So this is from minus 3 to 3 to 0 to 3. This is the point minus 3 comma 3, and here from 0 to 1 the graph is positive x. So we can draw the graph. So this is the point 1 comma 1, and now the function f circle g of x, we can define. First the function will be taken g from x to g of x, and then again the second function is f, so we can get the composite function g of f of x. So when x lies between minus 3 to 0, when x is for minus 3 to 0 you are getting negative of x, and you can see the graph. You can see the graph from minus 3 to 0 the range is from 0 to 3. So we can say the range is 0 to 3, and when the function 0 to 3 x value, and in the coming to the first function f in 0 to 3 you can see the range is from 0 to 1. We can see the range is 0 to 1, and in the second case when x lies between 0 and 1, And you can see in the function g, from 0 to 1 the graph is again 0 to 1. And again here from, we can say that the when x lies between 0 and 1, we can see the portion of the graph from 1 comma 0 2 by 3 to 1. So we can say 2 by 3 to 1, because 0 is excluded, so we can write close 2 by 3 comma 1. And to get the range of the function, range of f circle g of x, so can be considered these are the two sets union. So the set A union set B is nothing but 0 to 1 we'll get. So 0 to 1, which is option A. So option A is the answer.